some key things when we're solving. Okay? God bless you. So, looking at the first one, okay, this is very similar to the first warm-up we had, which again, saw definite improvement with this one. Okay, you want to take care of whatever's inside first. 1/4, you subtract x to the 4th, y cubed to the 3rd. So every piece you're raising to the 3rd power and also multiplying. So y to the 9th, 4 cubed, and x to the 12th. So at this point, we should know what 4 cubed is, which is 64. Okay, this is what we get for number 1. All right, so again, take care of your parentheses first. I saw a lot of you just get rid of that 3 first, which is also great. Okay, to get 8 over 5/12. All right, and then reduce. But why do all that when you're just going to reduce in the end anyway? Okay, again, either way works. Number 2, you have 27 to the 2/3, which is the cube root of 27 squared. What is the cube root of 27? 3. 3 squared is 9. Okay, then 125 to the negative 2/3. Cube root of 125. Negative second. What's the cube root of 125? 5. Can we have a negative exponent? No. This is not negative 25. 1 over 5 squared, which is 1 over 25. Okay? So the first 3 were pretty much identical to the first formative you had. So you should have seen improvement from the last one, or stayed the same. Okay? Now the last 3 are with solving. Okay? You have to isolate your parentheses first. Okay, subtract the 4. Was 32. You want to divide by that negative. Some of you just left it. Divide by that negative 1. Can you take an odd root of a negative number? Yes, you can. You could take an odd root of a negative number. When you take an odd root, either positive or negative, you get what you get. Okay? You see exactly what you get. So x plus 2 equals negative 2. X equals negative 4, which did work. Okay, so x equals negative 4 is your solution. Number 5, biggest mistake. When you take an even root, what must you include? Plus or minus. Okay, you have x to the 4th plus 9 is 90 equals 81. I am taking the 4th root. Automatically, I should have plus or minus. Plus or minus 3. Okay? And some of you got the minus 1 because of it. We do not forget the plus or minus. Okay. And the last one, okay, square, square, all right? So you have 3x plus 7. I should not see x squared plus 1, especially in this class. Honors level. X squared plus 1, I should not see. What should I see instead? Yep. Which ends up being what? Plus 1. Okay. Subtract the 3x, subtract the 7. X squared minus x minus 6. How do I factor that? Yep. What's your final answer? What would it be? What would factored form be? Yeah. Okay, so your two possible solutions were 3 and -2. However, -2 is extraneous. Okay, so if you just wrote on that blank x equals 3, you're correct. If you wrote both, then cross it out and put extraneous. Great. You don't have to put, which I've seen a lot, like in number 5, it was x equals plus or minus 3. Both of those did work. You don't have to include next to it, there's no extraneous solution. You don't even have to mention. Does that make sense? Okay. You only either cross it off or don't list it when you're giving your final answer. Okay? If you had 3 and -2 as is and didn't cross anything out, you would be marked wrong. Okay? We have to show that there's an extraneous solution. Okay? So if you look at the maze, just quickly, this makes you think a little bit. Okay? What is the -1/2 only affecting? Campbell? The 64. The negative is not affected by it. This -1 is not affected by it. So it's negative square root of 64, then to the negative first. What is the square root of 64? Okay. What is 8 to the negative first? So the answer would be -1/8, not -8. Okay. So as you go through these, just be careful with the mazes. When we get back from lunch, we're going to look at a different way of solving. Okay. It's very simple where you're looking for the same base. So this chart to the left, nope, to the right, okay, is going to give you an idea of what the bases we're looking for. All right. So we're going to pause right. Okay. This is the last piece and probably the easiest. The hardest part is to figure out what the base is, okay? A base is a number raised to a specific exponent, right? So the base has to be the same. Typically, our bases are small, so 2, 3, 5, 6, 7, so on and so forth. Kind of skip over 4 because the smallest base we see is 2, which is smaller than that. But there could be instances where you do use 4, so don't count it out too much. So for example, if we had 2 to the x plus 6 equals 32. Looking at that right now, you wouldn't be able to solve it without knowing either what a logarithm is, taking the log of either side, or graphing it, y1, y2. So instead, we look to change the base. So we have 2 to the x plus 6. 2 is our base. 32 we need to change with the same base. So we would want 2 to the x plus 6 equals 2 to what power gives me 32? The fifth. So this is what it looks like. We're rewriting 32 with a common base. Now, if the base is the same, you could drop down those exponents. Okay? If the base is the same, you could drop down the exponents and set them equal to each other. So x plus 6 equals 5. Our answer would be x equals -1. All right? So if we look at A, we have 4 and 8. Okay? 4 can't be a base because 4 to some power does not give me 8. So what's a common base for both of them? 2. Okay, how would I rewrite 4? 2 to what power? Go ahead, just say it out loud. 2, and then 3x plus 5. How would I rewrite 8 with the same base? 2 to what power? 2 to the third. Now, when you have something set up like this, what would you have to do then with your exponents? Grace? Good. So you would have to multiply. However, we have an expression here, a binomial. So we have to distribute. So it would be 2 to the 6x plus 10 Okay, make sure you're multiplying 2 by 3x and 5. Then we have 2 to the 12x minus 9. Since our bases are the same, and we multiply the exponents, we now can drop those down to get 6x plus 10 equals 12x minus 9. How will we go about solving? What do we get? What does x equal? Brian? Careful. Josh? 19.6. Subtract 10, subtract 12x. We have negative 6x equals negative 19. X equals 19.6 as our answer. Okay, and that's all we're solving for. That's all we're doing. Okay, now if you look at B, we have the same base all the way across. But what do we do with those two exponents on the left-hand side? Add them together. So since we have the same base, I could just drop these guys. Alright, so now we combine like terms. Negative 2x plus negative 2x, negative 4x. 1 minus 3 is negative 2, equals negative x. Did it the wrong way. Huh. Negative 2/3 is what you get. Okay? You're going to? Yeah. All right. So we're always looking for the same base. If you look at your blue puzzle, here are some ideas of some bases you will see on the right-hand side. Yeah. No. Mm-mm. Because here you're adding your exponents. So you would get 3 to the negative 4x minus 2. And then, so 3 minus 2 is 3 to the negative x. And then you're able to drop. Okay? So we're going to look at a few different examples on the next page. Look at number 2. How would you set that up? Yeah, right. 3 to the first power. So you have 2x minus 1 equals 1. Okay? 2x minus 1 equals 1 as your exponents of what you're bringing down. What do we get for an answer here? Andrew? X equals 1 because it's 2x equals 2. X equals 1. Okay? How about number 8? How about number 8? How would I rewrite that? What would I do? You have 3 to the 2x minus 4 equals 1. Grace? No. It's okay. You want the same base. Laurel? Why? Excellent. So you need the same base. Alright? You need the same base. So you have 3 to the 2x minus 4. You're rewriting 1 as 3 to the 0 because that equals 1. Okay? So now you are able to drop your exponents. So you have 2x minus 4 equals 0. What does x equal? Phoebe? 2. Good. Okay, very straightforward. The hardest part is figuring out the base. Right? If you look at number 11, and you always want to deal with whole number bases. Okay, you have 1/3 to the x plus 2 equals 9 to the 3x. 1/3 and 9 have what base in common? What is it? 3. Okay, good. So we could rewrite 9 as what? 3 to what power? Squared. Good. Okay. How would I rewrite 1/3? Right? 3 to what power? 3 to what power gives me 1/3? -1. Excellent. X plus 2. Okay? So we have our whole number exponents. We rewrote 1/3 to 3 to the negative first. Now we just multiply. So -x minus 2 equals 6x. What do we end up getting? What does x equal? Yeah, Andrew. -2/7. Good. All right, so we're going to try some practice. Okay, we're going to leave the last row for us to do together. So the ones I circle, number 1, number 4, number 6, 7, 10, 12, 14, 15, 16. Okay, the ones that are circled. I want you to try. Please. Okay, number 2, number 1, sorry, is x equals 2, which is the correct answer. Good job. Okay. Number 4 is x equals 13/4. Any questions about those two? Okay, pretty straightforward because it's already in the same base. You're just dropping the exponents. Number 6, good. X equals 8. Any questions about number 6? Okay. Then we have number 7, good, is no solution. Because when you rewrite them, all right, so you have 2 to the 3x minus 4. When you rewrite 8, you have 2 cubed. When you distribute, you have 3x minus 4 equals 3x minus 3. Your x's cancel out, therefore there's no solution. Any questions on number 7? Okay. Number 10, good, is 3/2. Any questions on number 10? Okay. Number 12. Someone get something different? Rory? -13/7. Okay. So for number 12, you have 1/4 to the x minus 1 equals 32 to the x plus 3. 4 and 32 have what base in common? 2. So, how would I rewrite 2 to what power gives me 1/4? Yep. -2 times x minus 1. 2 to what power gives me 32? 5. All right, so when I distribute, I have -2x plus 2 equals 5x plus 15. Okay, remember it has to go to both. Now I add 2x minus 15. So I have negative 13 equals 7x. Divided by 7. Negative 13 over 7. Okay. All right. Number 14. Someone get something different. Laurel? 10 over 7 is the correct answer. So, 125, how do we rewrite it? Yeah. 5 cubed. 5 cubed. 2 to 3 minus 2x. 5 to the x minus 1. So, you have 9 minus 6x equals x minus 1. Add the 6, x. So you have 9 equals 7x minus 1. Add the 1 to the other side. X equals 10 over 7 for number 14. All right, number 15 is correct, is negative 2. Okay, number 15 is correct, it's negative 2. Number 16, what do we get? I have negative 1 on the board. Someone get something different? Abigail? 3/5 is correct. So, with 16, 1/4 and 8 have what base in common? 2. 2 to what power gives me 1/4? 2 to what power gives me 8? 2 cubed, 3. Negative 2x equals 3x minus 3. We subtract 3x. Negative 5x equals negative 3. Divide by negative 5. X equals 3/5. Okay. So we have 4 to the x minus 1. Okay. 4 is our common base, or you could rewrite it if you wanted to 2. But 4 to what power gives me 64? 3, but since it's 1 over 64, what do I have to do? Negative. So 4 to the x minus 1 equals 4 to the negative third. X minus 1, negative 3. X equals negative 2. Okay? And if you just did 2 to the second and 2 to the negative 6, you would have got the same thing. Okay? You would just have a little more reducing. All right? Now, if you look at this last row, you have some square roots and some other stuff going on here. You have 3 to the x times 3 to the, equals 3 to the first times, how can I rewrite the square root of 3? Yeah, you. 3 to the 1/2. Now, on the right-hand side, what can I do with those exponents? Yeah. You could add them, but what do you need first? Yeah, Phoebe. Which would be what? 2. 3 to the 2 over 2. 3 to the 1/2. 3 to the x. Now I'm able to add. So x equals 3 over 2. Okay. Now if you look at 18, You have 5 to the x equals 25 times the square root of 5. What base do you have in common? 5, okay. How do I rewrite 25? 5 squared. How do I rewrite the square root of 5? 5 to the 1/2. Now, before I add them, I need a common denominator, which is what? 2. So I have 5 to the x equals 5 to what power? So what does x equal? 5/2. Good. Thank you, Rory. Okay. So you're rewriting to the same base in order to drop the exponents, in order to solve. Just another way of solving. Okay? Another way of solving when you have like bases. Okay? Probably the easiest one to do, because all you have to do is change it, distribute, and then drop the exponents. Right? So we're going to try 2 application problems before I tell you what your practice is. Okay? You guys have done these before. Right? We're going to set it up and solve. Number 1 and 2. All right, go ahead. What do we get for an answer? Good. Excellent. Okay. So they're telling you the surface area was 486. 6b to the 2/3. Divide by 6. 81. 2/3. You raise it to the reciprocal. Now, typically, if we were just solving and not for a specific word problem, what would we have to include? Yep. Plus or minus, because our denominator is squared. But since we're talking about volume, it's 2. Our denominator is 2. Since we're talking about volume, do I need to include plus or minus? No. So, the square root of 81 cubed is going to equal the volume. Square root of 81 is 9. 9 cubed gives you 729 inches cubed. Okay? How about number 2? How many hours? Phoebe? 14 hours. You're finding the when. Okay? T equals minus 1 to the 1/3. 1/3, it gives you the 14 hours. So, we completed all the solving, okay? All the solving that we will see with word problems, with same base, with raising it to the reciprocal if it's a rational exponent, squaring it, cubing it, fourthing it, depending on what root it is, checking for extraneous solutions. Then we did evaluating using rational exponents. We did rewriting both ways. We did exponent properties, a whole bunch of everything. Okay? Your homework is the blue sheet, the rational exponent puzzle. Okay? Then, on page 5, and you'll see at the top that it's labeled 6.6. Okay? Page 5, the circled problems. Okay? It gives you a little bit of all solving, okay, including the last piece at the bottom, which was changing the base. All right? You have about 8 minutes to at least start one of these things, okay? Rational exponent puzzle, just be careful of some of the negatives that are given to you.